Well, another Monday is here, and I was looking for something kind of interesting to hit you guys with, and I thought I would go over just a little bit of stuff related to hybrid and Tesla basics. This is not going to be a comprehensive course. It's going to tell you everything you need to know, because my goodness, it would take a long time to do that. I actually went to Craig Van Battenberg's Up Your Voltage up in in Seekonk, Massachusetts, way back in 2010, and learned some stuff up there, took some pictures, and that was a $3,000 4-day course that was pretty doggone intensive. Funny thing about Craig, if you came back late from a break, you know, he would make you do 25 push-ups. Of course, he would do them with you, you know. One time that happened, you know, but anyhow, that was funny. And he's a really knowledgeable guy. But anyway, I didn't learn everything I'm telling you here from Craig. I mean, I've done a lot of other studies on hybrid electrical stuff, and I taught it at the college for a while. So I'm just going to share just a few items. Just like I say, one of the first things I want to say is, you know, don't plow into this thing blind just because you've watched a video that anybody's made on YouTube or anywhere else and think you know all you need to know. You need to make sure that you have all of the information in front of you in full knowledge and understanding of what you're doing in your personal protective equipment. I'm not going to spend a lot of time talking about the gloves and all that stuff, but I am going to tell you, you need a Cat 3 meter, you know, that can handle 1,000 volts, you know, 600 to 1,000 volts or whatever, even though you usually won't be dealing with that much voltage, and so on and so forth. But let me move on here. And these are just a few quick pointers, and I hope you really enjoy it and get something out of it. And this right here is a Honda Insight, the hybrid, what you see under there. Now, this is not the newest one. This is an older one that I had a picture of, and it's okay. But I want you to look at that switch right there. It almost looks like a circuit breaker. On this Honda, you know, they do neatly put all this stuff under here. They don't use any kind of refrigerant or liquid cooling or anything on any of this. It's all cooled by fans. Now, this little switch right here, whenever you pull that little red thing off and you click that switch to deactivate, you know, to take that the batteries out of series, you turn that switch around, I mean, this red thing around, and put it back on there, and that keeps it from accidentally getting flipped back, supposedly. But there's your little switch on that one, on that Honda, where you do that. And this is an electric motor that's between this continuous variable transaxle and the engine, and it basically is a sort of an electric supercharger that assists the engine in driving the car. Of course, if it's assisting the engine, you're going to wind up getting a little bit better fuel economy for that reason. Now, the earlier Honda Insights, if you had issues with the other program, I mean with the other stuff that was supposed to start the engine and all, you know, this motor starting the engine and the circuits and all, they had Honda, in their simple and infinite wisdom, put a regular starter on that darn thing so that if it was necessary, you could start the car with a regular starter and drive it even if this system was dead in the water. Now, I don't know about the newer Insights, but I thought that was pretty brilliant. Honda thinks in a very simple fashion about a lot of their stuff. And even whenever I was studying gasoline direct injection and stuff, it always impressed me how Honda manages to keep things simple a lot of the time instead of making it more complicated than it needs to be. Alright, and this right here is the electric motor. Wait a minute, let me back up. I'm going to let you look at this video. This is a video that was taken at Craig's school. Let me see if I can get it to play. And I fooled around and made the video, but this is the motor on the bench. That's Craig there. And this little tool was made to take the rotor out because the magnetism holding it in there is so strong. I found out when he showed us this tool and we bolted it to that rotor that I could just grab that and snatch it out of there. You didn't need to screw that thing in. And after I grabbed it and snatched it out of there, Craig came over there and he tried to see if he could do that, and he grabbed it and snatched it out too. See how that magnetism snaps that thing back in there? It's pretty strong. Now, what you got to realize is on those electric motors, if it's a three-phase motor and it's brushless, any brushless motor has got to have some electronics that's going to walk the magnetism around those coils, and the permanent magnet is in the middle on the part that spins. You're not used to that if you're used to a brushed starter motor or something like that. Of course, they make brushless starters, brushless fuel pumps now, and they've always got some electronic device that's dialing in those, they're sending those 3 pulses to the 3 sets of windings to run the motor. Even a computer fan, and I've mentioned this before, if you take a computer fan, like in my PC over here, and you take that thing apart, you're going to see that there's a circuit on the inside of that fan behind the hub that makes it brushless. Now, you can't reverse the polarity on these computer fans and have them run backwards like you can a regular brushed motor. But the simple fact is, a brushless motor is like on the electric fuel pumps on some of these, electric water pumps, on the coolant pumps on a lot of these hybrids. They actually have a little brushless motor, and there's always, there's always some electronics that drives a brushless motor. I always thought it was interesting too how on these Honda hybrid AC compressors, it was a dual scroll. It had a scroll in the back that was driven by high voltage, and it had a belt driven scroll in the front. So you got them both on that one there. I thought that was pretty interesting how they came up with that idea. Although most of the hybrids and electric vehicles you see now have got a fully electric, obviously an electric vehicle is not going to have a pulley because there's nothing to spin it, but they basically have just an electric compressor. Now, one of the things you need to know is these high voltage windings in here have got some, sorry about my squeaking chair, but anyway, they've got some insulation on them that's susceptible to be damaged by conventional refrigerant oil, and so you need to use ND11 refrigerant oil. But check your specs just to make sure. The ND11 oil is not supposed to attack the high voltage windings that are present down here in the HV part of that AC compressor. You know what this is? Anybody seen one of those before? Some of you guys may know what it is, some of you may not. That is the resolver on the motor that helps the electronics to have optimum power in driving those motors, so it will know where the motor is and where to send the pulses to the 3 windings in there. Anyway, that's one right there that we had taken the transmission apart, and I had one of the guys that was working with me on the transmission we took apart, we were holding that in our hands, and I thought that was such a sexy looking piece of hardware. You can spin this with your finger, and that little gear almost acts like a miniature, see how it's got a little space over here and it's toothed over here. That sort of walks around inside there when you spin it. I thought that was pretty darn cool. I guess that's some kind of a pump so it can move the grease around. I don't know what the reason is for that. Hadn't studied those resolvers all that much, but a lot of these hybrid drive motors have got resolvers built into them, so just get used to that. They won't always look like that though. Some of them have just got Hall effect switches in there so that that does the same job as the resolver does. Now on the Toyota Ford hybrid transaxle motors, this would be like you see on your Ford Escapes, back when they, first started getting a lot of hybrids. You got MG1 and MG2. Now MG2 is connected to the Planetary ring gear on the little transaxle, and the sun gear is connected to MG1. Now MG1 is a smaller motor, MG2 is the larger motor. This is also the motor, and I'll mention this again in a minute, that turns into an electrical generator when the circuits are switched. When you hit the brake, this slows the car down because when you're generating current, you're going to basically create some resistance while you're doing that, and the momentum of the car is driving this, and it's causing it to put juice back in the battery, and that works pretty well. Sometimes when you're driving a hybrid and you're doing a lot of stopping or you're going down a lot of hills, you'll see that voltage in the battery go up a pretty good bit. On the Ford Fusion, the Ford Fusion's battery is just a 275 volt battery at its base with all of the batteries they have stacked together in series to make it. However, driving a 2010 Ford Fusion, I've seen that voltage on that battery go up to 400, 500, 600 volts sometimes on the one that we were driving when I was in school anyway. I don't know how the new ones do. The engine is connected to the Planet carrier. Now, one of the things I'm also going to mention later is anytime you put the vehicle in reverse, you're never using the engine to back up. The engine can only spin in one direction. the motors will spin in different directions to give you different gear ratios using the Planetary gear set. You remember, this is the variable. It's a variable excuse me, not variable geometry. I'm talking about turbochargers here, but a continuous variable transaxle, because it's got a Planetary gear set it uses connected to the engine and these two motors, that causes that Planetary gear set. But these motors may be turning in opposite directions. It's a crazy thing if you look at it on a chart. And Craig actually had a couple of motors set up so you could take knobs and make the motors go this way and that and drive the wheels on a little simulator that he had built. That was pretty doggone interesting and impressive, because he had a mock-up of it, you know, that you could actually play with there. And I had a video of us doing that somewhere, but I didn't put it in here. Anyway, remember, this is connected to the planet carrier, and when the planet carrier is stationary and you're driving the ring gear, you're going backwards. That's how that works. Now the sun gear, you know, will be still. The ring gear will walk, and it will cause the output, you know, based on the stationary. In other words, sun gear is stationary, and the planetary gears are stationary. You know, so they're actually, that's how you get reverse, is driving the ring gear while the planet carrier is held steady, and the sun gear. Well, and so anyway, I'm not going to talk a lot about that, but you know what I'm talking about. You're going to hold this one, you're going to turn that one, and you're basically going to be driving the vehicle backwards. Actually, I think the sun gear turns too, but the sun gear is driven by the planet gears by way of the ring gear. So it's easy to get messed up with that if you just start talking about it, you know. Anyway, this is the gear train power split device, is what they call the power split device. That's the engine, that's MG1, that's MG2. Notice MG, they got it color coded here. MG1, this is from Toyota, something I borrowed. But this MG1 is connected to this Planetary. See, there you got the colors. And this is the sun gear, and that's the ring gear. So it's a single Planetary, and that's how that operates. You know, you're used to all these compound Planetary gear sets and Ravino and all that stuff, and automatic transmissions. This transmission's got that one Planetary with these three different things that are driving it. Now this is early Toyota training on a hybrid transaxle. Now you can look at how the Planetary gear, see, that's MG1, MG2, and then there's your Planetary gear. That's starting out. Battery power only. Notice the engine's not running at this point. Alright, so we're going to do full acceleration. The engine kicks in. It also is going to run anytime you get it on max air. And you see how your inverter is basically driving that thing with power from the battery, and so on and so forth. You can see what these are doing here. You can rewind this and play it back if you want to, but you notice how you got minus and then you got plus on that one. See how they're spinning in opposite directions to give you the ratios and all that you got here? And I thought that's pretty interesting. This is reverse, basically. Alright, so this one right here is when you're deceleration and braking. Notice the power is driving, the power of the car is driving at it, and it's putting juice back in the battery. That's just a real quickie that you can look at. This is basically from a Toyota training course. Now, MG2 is used as a generator while braking. There's MG2 in this cutaway 2016-17 model Toyota transaxle. But notice the ring gear is here. There's your little Planetary. There's your sun gear, and then your planet gears. You can see that one there. And this is the outside of the ring gear has got gear teeth that match up with this, you see. And so basically you're going to have this MG2 driving that gear, and then this is your, you know, going to be your final drive, the way I understand it. But anyhow, that's a pretty cool thing there. I created this illustration, but that's what drives that. So the ring gear is still driven by MG2 in this one by way of this gear and that gear in this one. But like, once again, there's where your power split is for your differential and all that. Anyhow, that's a pretty interesting little thing. Now there's your basic high voltage layout. On this one here, the service plug actually interrupts the series of all these batteries. See, these batteries are basically stacked against one another, so you got a bunch of 1.5 or 2 volt batteries or whatever they are, and they're stacked together, and it gives you the high voltage, right? Well, when you pull out that, there's a fuse in this. That's why they show that little fuse right there. When you pull that service plug out, and this would be on like a Toyota Prius or whatever, then you're going to basically kill the battery so there's nothing there. Okay? On these are contactors, and anybody that knows anything about high voltage, like using air conditioners and all, contactors are big heavy duty relays, And since you've got so much voltage there, and you know how voltage likes to arc and burn things up, you know, on our points, in our old points ignition systems, we put a condenser in there, which was actually a capacitor. And whenever the points opened, it didn't spark. If you didn't have a good condenser, of course, it wouldn't run right, because that condenser also, when the points close, it helps charge the coil up real quick. But it also kept the spark from happening and burning the points up as fast. However, in this, in order to keep them points from burning, they want to slap those things together just as hard as they can. That's why they call them contactors. And that's just a generic picture of a contactor, like what you'll find. This same kind of contactor basically is what you're going to see in a Tesla too. All right, but that right there is your inverter. And your inverter is basically going to have some cooling. It typically will be liquid cooled on just about everything except a Honda, unless the newer Hondas have got liquid cooled inverters. Last I knew about the Honda Insights, they were using air for everything. They'd use the air from inside the car. Cooling the battery and stuff, the battery's going to be cooled too. On the Ford Escape, they actually have a dedicated air conditioning evaporator to keep the battery cool. So you don't want the battery to get too hot on a hybrid. You know, we always think of it, we don't want the battery under the hood getting too hot either. That's why we put insulation around it so it doesn't boil the acid out of it, you know, make a big mess. But anyway, that's the point. And there's your service plug. This is two of those relays. Now this other little relay, actually before these relays contactors snap shut, this other little relay will close, and that is a test of the circuits to see if there's anything shorted. One of the things you might want to notice is no part of this high voltage system is shorted to ground anywhere. In other words, if you've got your high voltage low and your high, none of those are grounded to the car body. And the stuff inside the car is still driven by a 12-volt battery. And so, you know, they don't want to have, you know, 300-400 volts in here and all these knobs and everything in the dash. That's kind of dumb. So they use a 12-volt battery that's hooked to this system. Then it's not shown here. I'll show you that in a minute on something that I drew. I got this from a guy that teaches hybrids in California. He gave me permission to use this. That's why I'm using it. Now this right here is a 2010 Ford Fusion. The contactors are in here on this one. This is behind the seat. And you got to know how to take that seat cushion down to get to this stuff on this Fusion. It's really tricky. I'm not going to go into that. But that's your battery pack sensor module. That's your battery energy control module. And all that's back there, right behind the seat. And there's the plug. See the service plug? When you pull that service plug out, it's just like that other orange one I showed you earlier. Okay, there's when the service plug's been removed, see? And these right here are the connections in there. You see that little wire right there? That wire right there, as I remember, is supposed to help check the integrity of the other wires before it ever snaps the contactor shut. You might also notice there's an inductive current feed right here. Now you got contactors here. There's a low voltage fuse right here that puts out, that's where the 14.5 volts goes out to charge the battery. If that fuse blows, the way you can tell if the battery's charging on a hybrid or not is you can take your meter, and you know you're obviously supposed to have your gloves on and this kind of thing, but you take your meter and you connect it to the battery, and then you energize your hybrid system, let the contactors close and all. You should start seeing 14.5 volts of that battery coming out of the electronics as part of the hybrid stuff. So, and that fuse right there on the 2010 Fusion is back there. And if that fuse blows for whatever reason, you'll have, you know, the 12-volt battery will try to go dead. But anyway, you can kind of get an idea what these electronics are like. This is with the cover removed and all that, and the contactors are here. So they look a little different from the one I showed you, but they actually have some pretty interesting electronics on that thing. Now, hybrids that use a series drivetrain only receive mechanical power from the electric motor, but in a parallel hybrid drivetrain, it's either the electric motor or the gasoline engine or both simultaneously. Reverse is almost always all electric on these things. Extremely basic parallel drawing. This is very basic. I drew this. I didn't get it from anywhere else. And so, you know, if some of you people that know a lot more about hybrids than I do tell me that I didn't draw this right, so be it. But this is basically the way it works. You got a DC to DC converter. Incidentally, some of the Toyota Highlanders had DC to DC converters, the hybrid Highlanders, that were going bad when the car wasn't that, you know, when it was about time it went out of warranty, and it was like $10,000 for a DC to DC converter. I don't know how much they are now. They may be cheaper now. But there's a DC to AC inverter here that's going to put out 3-phase high voltage to these motors. And you know, they basically got the 3 windings, you know, labeled like you always, WVU or whatever it is. You know, I don't ever try to memorize that. And you know, this is just the way that I put that together. And there's your, you know, your final drive, your power split device right there. It's operated by MG1, MG2, and I drew this in a way that made sense to me. Whether it makes sense to you or not, I don't know. High voltage battery is usually always in the back. Of course, in a Tesla, it's the whole floor pan of the car, you know, and the electronic stuff is up under the back seat on those. But the 12-volt battery is getting 14.5 volts out of this DC to DC converter, and so you got to take DC and change it to AC to operate these motors, and that's what these inverters do. And typically, every motor will have its own inverter. You see, that's just the way that works. Of necessity. And so battery requires special cooling, should run between 40 and 80% charge. You know, we're basically used to the batteries, you know, charging a battery up to 100% on our phone and letting it run all the way down. Well, even on a phone, you can charge a battery too much and it'll start to swell up and cause you problems and all. But this one here, you're basically the optimum charge for battery life. I'm talking about long-term battery life, is to keep it between, you know, 30 and 80 or something like that, you know, but charging it to 100% is something that the hybrid material that I have studied and taught had basically said that on a hybrid. Now, I'm going to tell you that if I had a choice between a hybrid and an electric and I had to pick one, I would pick a hybrid over an electric any day, because they have plug-in hybrids, and that's okay, but I like being able to put a little bit of gas in there and let this thing be self-sufficient. You understand what I'm saying? Alright, now this one right here is a series drawing. You notice this generator is basically charging the battery, and the battery is all that drives the vehicle because it's only got one motor. I just left that labeled MG2. I didn't change it, but I modified the drawing on that. I hope you got something out of that. Electric vehicles add a load to the power grid. Hybrids can charge itself using a small amount of gasoline typically. Now that's a general statement, I understand that. Alright, so on a Tesla, to disconnect the battery, you're supposed to disconnect this loop. Now it won't be in the same place on every Tesla, but typically it's going to be in a place that's easy for the first responders to find it. The first responders, if they can get the hood open, can typically always find this orange thing. They're supposed to cut it in 2 places where it can't accidentally touch back together. So what it does is, you disconnect it when you're getting ready to work on it. Now there's a procedure you're supposed to go through when you do that. You're supposed to have everything shut down, and you're supposed to disconnect that. And you know, when you're changing a 12-volt battery, I mean, there's procedures to go through, so don't feel like it's okay just to fly in here and jerk that thing loose and do a bunch of work without following shop procedures. You gotta have literature for you that you can use that's reliable on telling you how to do this stuff. But that's what the first responder loop looks like. I had a whole bunch of other pictures of it. But you have to disable, that disables the contactor coils. Now the problem with contactors, and one of the reasons that even after you have disabled, like on a hybrid or whatever, or on one of these, if you have actually disconnected, you need to make sure there's, well, on the hybrids you got to wait till these big capacitors in that system bleed off, so that you don't get surprised by some voltage you didn't expect. On this one here, it's a possibility that the contactors may have welded themselves together on one side or the other, because your negative and your positive side both have contactors, you know. And so if one of those is welded together, you may have some voltage in a circuit that's going to send you to checking those contactors and see if they need to be replaced. On a Model 3, you don't cut. I mean, it has a wireless, a first responder loop too, but it's hardwired so that you can't unplug it like you can on the S and the X and those. On the Model 3, you've got to get under the seat. They call this thing back here the penthouse, believe it or not. And you've got to unplug this right here. And then there's a place on the other side of that, which I didn't picture, where you're supposed to take a special cover off and go down in 2 holes with your meter and check and see if there's still voltage, to see if maybe the contactors have welded themselves together. But like I say, don't take what I'm telling you and fly in here and think, hey, I can work on Teslas and hybrids now. you got to get the proper training. You got to get the proper literature. This is just giving you some, few quick highlights here. On all Teslas, you need to check for voltage after disconnecting in case the contactor is stuck. That's what I put on there. These are only quick pointers. There's a lot more you need to know. It's not presented here. Make sure you have adequate training and literature for the vehicle you're servicing. Always follow safety protocols in every circumstance. Now, this isn't a very long video, but I have been throwing some little practice tests out there for electrical and engine performance and stuff like that. And I really hope you guys are appreciating those. I'm going to bail out on you right now. There's a lot I got to do today, and I'll talk to you next time. I'll come back now, see ya.